The next method is that is again from alcohol, but the reagent is phosphorus halides, phosphorus trihalide, phosphorus pentahalides, okay, which are represented as px3 and px5. The chemical equation is alcohol when that be treated with phosphorus halide. Let us consider the trihalide fast, px3. As a result of the chemical reaction, you will get the corresponding alkyl halide, and the side product formed here is S3PO3, phosphorus essentially. Okay, one px3 molecule that reacts with 3 alcohol molecule, and the reaction results in the formation of 3 alkyl halide molecules. Here X, it may be iodine, bromine, chlorine. So before moving towards the mechanism of this reaction, it is quite necessary to know some noteworthy points here. First, this method is particularly applicable for the preparation of primary or secondary alkyl halides. Tertiary alkyl halides cannot be prepared easily because the starting material is alcohol. If I need to obtain primary alkyl halide or secondary alkyl halide, then I need to consider the corresponding primary alcohol or secondary alcohol. Whenever I will use a tertiary alcohol with phosphorus halide, generally tertiary alcohols, they undergo elimination instead of nucleophilic substitution. Our motto is to prepare alkyl halide. And in order to prepare alkyl halide, the alcohol has to participate in nucleophilic substitution reaction. Okay, this OH group that is to be substituted by the halide ion, that is nucleophilic substitution. But whenever tertiary alcohol be used, that undergoes elimination reaction resulting in the formation of alkenes. Okay, so that's why it is not a suitable method for the preparation of tertiary alkyl halides by this method. The second point, these reactions, they do not involve rearrangement. In the previous step, whenever we were dealing with the preparation of alkyl halide from alcohols by using halogen acid, in certain cases rearrangement was involved. No? But here we need not to worry about the rearrangement. We need not to think about the migration of hydride ion or alkyl group. Okay, let me consider some example. CS3, CS2, CH2, OH, N-propyl alcohol. When it be treated with phosphorus tribromide, PBr, then as a result of their reaction, we will get corresponding alkyl halide CS3, CS2, CS2, Pr plus S3PO3. In order to balance the equation, I need to multiply 3, also 3 with the product. Okay, N-propyl alcohol, that is giving rise to what? The formation of N-propyl bromide. This phosphorus tribromide, it can be generated in situ. In the reaction medium, we can prepare PBr3 by taking the mixture of phosphorus and bromine. Instead of taking PBr3, we can use this mixture, red phosphorus and bromine. For example, this is another alcohol molecule. Let us consider secondary butyl alcohol. When secondary butyl alcohol that we treated with this mixture, red phosphorus and bromine, and the mixture be heated, you will get the corresponding alkyl bromide, means secondary butyl bromide. Plus the side product is S3PO3. This is your alcohol molecule. we are taking the mixture of red phosphorus and bromine. Just to balance this equation, I need to multiply certain coefficients here. 3Br2 2P. The mixture of 2P and 3Br2, they will form 2PBr3 molecule. 1PBr3 that reacts with 3 alcohols. So here 2PBr3, they will react with 6 alcohol molecule. As a result, 6 alkyl bromide and 2 S3PO3 molecules will be formed. Okay. If I need to obtain alkyl iodide, then I need to take the mixture of red phosphorus and I2 in the same way. Pi3, that is very much unstable and that is prepared in situ. So red phosphorus and iodine, this mixture is to be taken just to get Pi3. So here also the same coefficients are to be put. As a result, 6 alcohol molecule will participate and we will get corresponding alkyl iodide and propyl iodide that will be obtained here along with the formation of 2S3PO3. Okay. So this is about the use of phosphorus trihalides. In the same way, we can expect the formation of alkyl chloride where the alcohols they get treated with PCl3, phosphorus trichloride. But the yield of the reaction of alcohols with PCl3, that is very poor. That is due to weak nucleophilicity or weak nucleophilic power of Cl- ion. When we will use PBr3, Br- that will act as the nucleophile. When Pi3 be used, I- that will act as the nucleophile. Later on we will find the mechanism also. And when PCl3 be used, Cl- is the nucleophile. And if we compare the relative nucleophilic power, Cl- is the weakest nucleophile among Cl-, Br- and I-. Okay, so the yield of this reaction is very poor when PCl3 be used. Okay, next come to the mechanism of this reaction, mechanistic pathway. In order to get the mechanism of this reaction, let us consider one of the very simple alcohol molecule, CS3 CS2OH, ethyl alcohol. When it be treated with PBr3, according to the previous discussion, we should get ethyl bromide as our product along with the formation of S3PO3. So step by step we need to discuss the mechanistic pathway here. In the first step, this alcohol molecule it reacts with phosphorus tribromide. In phosphorus tribromide, 3 polar bonds are there. Br, these are the more electronegative stresses. Partial negative charge will be developed over this Br and partial positive charge will be developed over phosphorus. In the same way here, partial negative, partial positive, partial negative, partial positive. Sufficient positive charge will be developed over this phosphorus atom. This alcohol which contains oxygen with a lone pair of electrons through this atom, it will attack this phosphorus atom. Simultaneously, one of the phosphorus bromide bond, out of these 3 bonds, any one of the bond will be broken, which results in the release of one Br- ion. This is Br- that is going to be released, and in the next step this Br- is our nucleophile. The rest gases, they can be presented here: CS3, CS2, OH. Oxygen is now attached to phosphorus, which contains 2 bromine. oxygen will have positive charge. Okay. Now this is the nucleophile and it is your substrate. This Br minus that will attack to this carbon center. The entire group here, this will act as the leaving group. The leaving ability of this group is more as compared to the simple OH group. When Br minus that will approach this substrate, the reaction undergoes through SN2 mechanism. Remember here, SN2 mechanism. Primary alcohol and secondary alcohol, they react with phosphorus trihalides through SN2 mechanism. Nucleophilic substitution bimolecular. Okay. SN2 mechanism, as a result of this reaction, the nucleophile that attack the substrate in a direction opposite to that of the leaving group. Now, so you will get your product CS3 CS2. This Br, when a bond will be formed between this carbon and this Br, simultaneously this bond will be broken, because we have learned in SN2 mechanism, bond making and bond breaking, they occur simultaneously. So a new bond is going to be formed between this Br and this carbon, and this carbon oxygen bond will be broken. You will get CS3 CS2 Br. The side product is HOPBr2. Okay. So out of 3 alcohol molecule in the first step, 1 alcohol molecule has participated, resulting in the formation of 1 alkyl bromide, ethyl bromide. This is not the final product here. In our net reaction, we have not mentioned this HOPBr2 molecule as the final product. Okay. In the second step, another alcohol molecule that will react with this side product that has been obtained in the first step. Okay. HOPBr. Once again, this phosphorus atom, this cycle atom that will develop positive charge due to presence of this kind of electronegative atoms. Then this oxygen that will approach this phosphorus, and in the same time any of these 2 phosphorus bromide bond will be broken. In the next step, bromide ion that will be formed, which will act as the nucleophile. In the incoming steps, the remaining species present here, CS3, CH2, OH, P. This phosphorus, now it contains only one bromine and one OH group. Okay. Next, as I told you, this Br minus, which has been obtained in first step, that will act as the nucleophile in the next step. This Br minus, it will attack this carbon center. Now this would be your leaving group. This is your leaving group. Then what you will get as a result of the attack of this bromide to this carbon, you will get CS3 CS2 Br, along with the formation of PBr OH hold. Okay. The second ethyl bromide has been formed. The second alcohol molecule that has been participated out of 3 alcohol molecules. It is the first alcohol, this is the second alcohol, and another alcohol molecule that will be participated here. Let us consider the third alcohol molecule. Okay. This alcohol not only that will react with which species? This is the species that has been formed as side product in the second step. Okay. This alcohol molecule, now it will react with this side product. What is the side product here? PBrOH. This alcohol, when it will approach this phosphorus atom, this third PBr bond will be broken. The steps are quite similar. When this bromide ion that will be released, resulting in formation of another substrate molecule. What is the substrate left here? CH3CH2. OH. This oxygen now it is attached to the phosphorus atom containing 2 OH group. 2 OH group. This oxygen will have positive charge. Okay. In the previous steps, bromide ion. This bromide ion that was acting as the nucleophile and that was reacting through SN2 mechanism. These mechanistic steps are SN2 mechanism. Here also, this bromide ion that will attack this carbon, resulting in the release of this leaving group. This is your leaving group in the third step. Then what you will get, CH3, this is CH3, CH2, CH2, this bromide ion that will be with the carbon. So this is the third ethyl bromide, along with the formation of what is the side product here? Phosphorus that contains 2 OH previously. This is another OH. So POH whole 3, which has been written here as S3PO3. Okay, this is third ethyl bromide. In this way, it is first ethyl bromide. This is second ethyl bromide, and this is third ethyl bromide formed. 3 ethyl bromides were to be formed. So these are 3 ethyl bromides, and this will be the final side product, S3PO3. That is the written here. Okay. So always remember, primary alcohols or secondary alcohols, they undergo reactions with phosphorus trihalides through SN2 mechanism. If we analyze the stereochemical aspects of SN2 reactions, then we have learned SN2 reactions involve inversion of configurations. No? The configuration of the product formed that has inverted configuration as compared to the substrate molecule. Then this alcohol molecule that can be presented here as this is your alcohol molecule. When it is to be treated with phosphorus tribromide, in the first step, this oxygen that will approach this phosphorus center, resulting in the release of one bromide ion, and this is substrate molecule left. This oxygen now is coordinated to phosphorus, which contains 2 bromide. This oxygen will have positive charge. Okay. In the next step, this bromide that was attacking the carbon center from the back side. This bromine that will attack this carbon in a direction opposite to that of leaving group. This is your leaving group. Okay, this is in accordance with SN2 mechanism. A bond will be formed between this bromine and carbon, and this carbon-oxygen bond will be broken. As a result, you will get your product bromine. Now it is attached to the carbon. The orientation of the atoms or groups present around this carbon will be inversed. Okay, this is called inversion in configuration. If we compare the configurations of these 2 molecules, this is your alcohol molecule, the substrate molecule, and this is your final product. If we compare the configurations are quite opposite. This is simply due to the SN2 mechanistic pathway. Okay, you need to think about it. There is inversion in the configuration whenever this alcohol molecule they will react with phosphorus halides. So by using this concept, we can find the answer of this question. This is one alcohol molecule and that is to be treated with phosphorus tribromide. Then what should be our product? Okay. Listen, whenever alcohol that is treated with phosphorus tribromide, the product is alkyl bromide. Just to get the product, simply we need to put a Br bromine in the place of OH. Simply the OH that is to be replaced by Br. Okay, because these reactions they do not involve rearrangement, so we need not to be confused. Simply just put the halide ion in the place of OH of alcohol. So similarly, we can put Br in the place of OH. Okay, whenever we will put bromine in the place of OH, we could get our product. But we need to specify the stereochemistry of the resulting product here. As I told you, this reaction occurs through SN2 mechanism. Then inversion in configuration occurs. So taking into consideration the inversion in configuration, the orientation of the bromine, which is to be placed here in the place of OH, as the configuration will be inversed, bromine now that is to be oriented in the opposite side, and the hydrogen atom, this is to be oriented in the opposite way. So this is your final product. No doubt, simply we need to put bromine in the place of OH, but the configuration is to be inversed. Okay, this will be your final product. This is what? 1, 2, 3, 4, 5. Pen, single bond, pentane, 2 or this is 2 bromo pentane. And just to have the idea about their configuration, so we can use RS notation. Next, we will use phosphorus pentahalide with alcohols. When alcohol molecule that we treated with phosphorus pentahalide, then as a result of the chemical reaction, you will get the corresponding alkyl halide. The side products are phosphorus oxyhalide or phosphoryl halide and corresponding acids. For example, when N-butyl alcohol that we treated with phosphorus pentahalide, we will get corresponding alkyl chloride CS3, CS2, 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 Cl plus phosphoryl chloride and HCl. Okay. In this method, generally it is quite convenient to prepare alkyl chloride. We cannot obtain alkyl bromide or alkyl iodide to prominent amount, because in order to get alkyl iodide we need to use Pi3, but Pi3 that is very unstable, that cannot be stored. For that reason, this is generally preferred for the preparation of alkyl chloride. Here also, if we use primary alcohol or secondary alcohol, then the reaction that occurs smoothly in order to form the alkyl chloride. But tertiary alcohol, they undergo elimination reaction instead of nucleophilic substitution reaction, and they result in the formation of alkenes. Here also, tertiary alkyl halide cannot be obtained. Okay. If we talk about the mechanism of this reaction, then let us consider one simple alcohol, ethanol, When that be treated with phosphorus pentachloride PCl5, then we will get CS3 CS2 Cl ethyl chloride plus POCl3 plus HCl. This reaction, this is to be investigated. We will find the mechanistic approach here. Okay. This ethyl alcohol molecule, this could be presented like this. When it be treated with PCl5 phosphorus, it has got 5 chlorine atoms around it. Let me specify 1 chlorine specially. Out of 5 chlorine, I mentioned 1 chlorine phosphorus bond here. Okay. 5 electronegative atoms, they surround the central phosphorus atom. Due to presence of these 5 electronegative atoms, sufficient positive charge will be developed over this central phosphorus. When oxygen that will approach this electron deficient center, this phosphorus chloride bond will be broken. Out of 5 phosphorus chloride bond, only 1 bond will be broken, resulting in the formation of 1 Cl minus ion, and the species left here this oxygen that is now coordinated phosphorus, which contains 4 chlorine atoms. This oxygen that will have positive charge. Okay. In the next step, the Cl minus, this will act the role of nucleophile, and that will attack this carbon center in a direction opposite to this leaving group. This is your leaving group. This group has higher leaving ability as compared to the simple OH group. Okay. So when Cl minus, it will approach from the backside. Simultaneously, this bond will be broken. This is in accordance with SN2 mechanism. Once again, we need to remember, primary and secondary alcohols, when they be treated with phosphorus halides, they undergo reactions via SN2 mechanism. And as a result of this reaction, you will get your product Cl. Now the configuration of the product obtained, that will be opposite to that of the substrate molecule. This is your product ethyl chloride CS3 CS2 Cl. This is ethyl chloride. If we compare the configuration of these two molecules, they have opposite configurations, and the inversion in the configuration, that is simply due to the SN2 mechanism. Okay. During the use of phosphorus trihalide PCl3, PBr3 or Pi3, the inversion in the configuration was solved. Okay. The side product formed here is, this is your leaving group. Okay. The product obtained here, HOPCl4, this is quite unstable and readily it dissociates into HCl plus POCl3. So HCl and POCl3, these are the final side products along with the formation of the ethyl chloride molecule. This is your ethyl chloride, and this side product that has been split into HCl and POCl3, HCl and POCl3. So this is about the mechanism. So here this point is to be remembered. These reactions, as they proceed via SN2 mechanism, the inversion in configuration is to be solved. By applying the concept, we can find the answer of this question. The question is, if this alcohol pentene that be treated with PCl5, then what would be your product? Okay, this is quite similar to the previous question. In the, this is OH group because it is one one of the alcohol, pentane 2-ol. Here in the place of OH we are getting Cl. So just put Cl in the place of OH, you will get a product. But in order to specify the stereochemistry of the resulting product, we need to use the concept of SN2 mechanism. Okay, the inversion of configuration. That is, your product that will have inverted configuration as compared to this substrate molecule. So, in order to invert the configuration, we need to put the Cl in the opposite direction as that of OH, and H that will be oriented in opposite direction. Okay, so if we compare the configuration of these two molecules, they will have opposite configurations, and this is your product 2-chloropentane. Okay.